Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome back in lecture 5, and in this lecture inshallah we will cover an example. In lecture number 3 and 4 we will explain the introduction, while in lecture number 1 and 2 we basically explain how to determine thickness in case of a DDM method. Okay, so these are some recaps, okay, of lecture number 3 and 4. You see how we have to choose exterior frame, then we divide that interior frame into column strip and half middle strip and half middle strip, and then we extract our exterior frames, and then we divide that exterior frame into column strip and middle strip. Okay, so let's start the example. We have this example, and remember there are no edge beam. Edge beams are the parameter beams which are provided at the parameter of the slab system, and we have no interior beam. Already we covered this example and by movement coefficient method, okay, ACI movement coefficient method. But in that case we have beams, and when you have beam you can analyze that slab system by DDM as well, but the coefficient will be different, the moment distribution coefficient will be different, and but that kind of slab system is a little bit complicated, and then therefore they're basically excluded from the coursework of the BS. One thing you must remember, you cannot use the ACI movement coefficient, okay, for a flat slab system like in this example, the slab system we have, remember. And one thing remember, that when you have edge beams, you have different basically the procedure for determining the slab system, different formulas for determining the slab thickness of the slab system. Okay, if you have interior beams, then the formulas will be different for determination of the thickness of, and I already explained this in my lecture number 1 and 2. The question is simple: live load given, you have to determine the dead loads, the material properties are given. What we have to do, we have to find out the thickness of the slab system. I already explained this, as we have no edge beams and we have no interior beams and we have no drop panels, so that's why I'm using ln by 30. If you see the table, like let me show you, without drop panels, and we have no edge beams, we have without the drop panels and the exterior panels. Okay, for interior panels you have to use ln by 33, so you can use this coefficient as well as this coefficient. You have to select the larger one. Okay, so L by 30 will give you larger value, so that's why I skip this and I use that one. Okay, you have to check for both, okay, remember, and you have to determine your ln. Now ln is what? Ln is your larger dimension. Okay, as you see, the frame is basically in the east-west direction. Okay, this is east-west direction, and this is your north-south direction. So in east-west direction the length is larger, that is 25 feet. So that's why we are using 25 feet. And how we can determine ln? So this is simple: 25 minus column size divided by 12 and divided by 30, you got 9.53, say 10 inches. And then we need to determine the effective dip. So remember, in flat slab system, remember, there are basically, let's say this is my bottom bar, okay, and that is my top bar. Okay, so the effective dip is counted from the top face of the bottom bar to the top edge of the slab system. This is D. Okay, and the clear cover is 3 by 4 inches. This is we are providing a slab, and the diameter which I am assuming here is number 6. So number 6 divided by 8 give you 0.75. So this is basically 6 divided by 8, this one, and this is your clear cover. You see here, this clear cover is basically this one. Okay, and the HF is your total thickness of the slab. Okay, so this is the procedure that how we will determine D. Okay, then you need to find out dead load, live load, the same procedure, and then you have to factor it. Okay, now from here basically our analysis start. Remember, DDM is analysis technique, not a design technique, remember. So we have to select our EW interior frame, not exterior frame. For exterior we will do the analysis in later stages. You see the columns, okay, and the frame is basically divided into, remember, this is this from this blue line to this line, this is my interior frame, and from this blue line to this line, this is my exterior frame. So here you see, and this is interior frame. L1 is center to center distance in the analysis direction. Remember, east west direction. If we are in analysis, start analysis in north south direction, then L1 will be different. It will be rotated. Remember. Now L2 is what? L2 is from the panel center line to the next panel center line. Remember, this is L2. And how we determine it, I already explained this in 3 and 4 lecture. Now you see middle strip, column strip, and middle strip. I already explained these in this diagram. You see in lecture number 3 and 4 that if we have an interior frame. Okay, once you got your interior frame, so remember, interior frame will be this one, the panel which the adjacent panel. Remember the adjacent panel. So let me show here. Okay, here you see this is basically L2 distance. Okay, this is L2. This whole is basically in between these two continuous lines. This is interior frame in east west direction, and this L2 is how much? This panel length, which is 20 feet, 20 divided by 2, which give you this half distance, while in that direction also we have 20 feet, so that 20 divided by 2 give you that half distance. So you L2 is what? L2 is nothing, it is 20 divided by 2 plus 20 divided by 2. I think so it will be now clear. Okay, and then you have to find out your column strip width. You know about your column strip width. What is column strip width? Remember, this is, okay, this half width. This is the total is column strip, but this is half is column strip width. Okay, and now we have to determine it. So the formula for this, you see here, the least of L1 divided by 4 or L2 divided by 4, and it is clear that L1 is 25, L2 is 20, so this one will govern, and it will give you 5 feet. And 5 feet, remember. Now how you can determine the rest of the widths? Okay, remember this length is basically 5 feet. This is 5 feet, so this one will also be 5 feet because this is also column strip divided by 2. Let me show here. Remember, this is 5 feet. Okay, from the column center line, as this is C is divided by 2 from the column center line. Now this is 5 feet, so the other side will also be 5 feet. Okay, now half middle strip and half middle strip, how much it will be? Remember, this is total width of this panel is L2, that is 20 feet. Okay, this is 20 feet. So L2 minus 10 divided by 2, so that will also be 5 feet. Okay, if the panel widths are different, like you see here in this case, let me show you here. If the panel let's say this panel width is 15 feet and this panel width is 20 feet. So then the calculation will be different. Remember, that middle strip will be different and this middle strip will be different to this side. So you have to remember these things. Okay. Here we are using, remember, the simple calculation. We say that the panels are at equal distance. Okay. If this is different, so then you have to find out a different approach. Okay, remember this half middle strip will be, now if this is, let's say this is 15 feet as I assume, so then this is 15 divided by 2. Okay, 15 divided by 2 minus this 5. Okay, so that will be your middle strip. So remember, if in question comes the panel widths are different, then you have to do that calculation. And most of the students are confused in this because they say that you are doing the analysis for simple system, like as I am assuming here 20 feet this one, 20 this one, 20 this one. But if they say that if this is 15 and this is 20, so how we can do analysis? So the procedure is same. You just need to understand concept. Okay, what will be L2 in that case? Let's say I write here L2 will be in that case 15 divided by 2 plus 20 divided by 2. Okay, this is the way. Now in that case, if you are in middle strip, remember middle strip, like middle strip will be here. So that side middle strip will be different and this side middle strip width will be different. How? You determine your column strip width, that is 5 feet. But for that, okay, but for that, remember this is your 15 divided by 2. This length is 15 divided by 2. This length is 15 divided by 2. So you have to subtract your column half strip width. This will give you the width of that middle half column strip. And for this you have to do what? You have to 20, let's say this is 20s. Okay, you see here this is 20. So this is 20 divided by 2 minus your column strip divided by 2. So this is the way. This is very simple. Okay, so you don't need to be confused if these spacings are different. Let's say this is 15, 20, this is 25. So you have to check the limitations as well. Okay, and okay, you got your column strip width, middle strip width. Okay, now you need to find out your m naught. This is L2 square. No, this is square, this is not square. Okay, so ln square. So please confirm it. This ln is how much you see here. Okay, remember I graphically show here 25 from the center of column to the center of column. If these columns are square, then you just simply 25 minus size of the column divided by 12. If these are different, then you have to use this one. Okay, it comes out to be 23 point something, and you square it and then multiply with L2 and with WU divided by 8, you got this one. Okay, now you have to distribute this movement first of all in longitudinal direction as I explained in lecture number 4, and then in transverse direction. Okay, this is very important. Now you see here this one. Okay, this one where we have, okay, now you have to distribute now that 540. You just write down 540. You have to distribute longitudinally. I explained this thoroughly in lecture number 4. From where these coefficients, these are ACI coefficients. So you have to take 26% for exterior, 52% for exterior positive, 70% for interior negative, 65% and 35%. Okay, let me write down. This is roundabout. If I choose 0.35 times m naught is 540. So 540 is 189. This is 189. Okay, this is 198, 189. Sorry. Now you have to distribute these movements in this direction, this will be in this direction, in this direction, similarly this one in this direction. Okay, this means that how much movement will be absorbed in column strip while how much movement will be transferred to the middle strip. So the procedure is simple. You have to use these coefficients. Okay, and I already explained that 100% will be absorbed at the face of the exterior column here and here. Remember the column which is here. Okay, 100% will be absorbed here and 0% will transfer to that side. Clear? This is important. And 140 will be let me show here. Remember here, right? Okay, 140 movement will be here. Okay, at the face of this column here, and 0 will come here and 0 will come here. Okay, this will be clear. And remember 60% of m naught. Remember 60% of m naught. Not of m naught. Clear? This is, remember, removed. Again remove it. This is 60% is of this 281. 60% of 281 will be here. Let me show you 0.6 times 281. That is 168. 168 will be here. 168 will be here, and 20% will be here. Let's say 20% times 281. I think so. 281. So 281. 20% of 281, that is 56. So 56 will be here. Comes here. Okay. 56 will become here, and 56 will be will be 2. Okay, this will be clear. 56. Okay, and okay, let me show here. At this point you have 168 movement will be absorbed here, and 56 will come here, and 56 will come here. Clear? Now again you have to take what 75% will be absorbed here. 75% of what? 75% of 378. Remember, 75% of let's say I take 0.75 times 378. So 378 give me how much? 283. So 283 will be absorbed here. 283 will be absorbed here. Okay, while 12.5 will be here and 12.5 will be here. Let me 12.5.125 times 381, I think so. 378, sorry. 378 times 378 give me how much? 47. So this means that 47 will be here and 47 will be here. Clear? This is important. So this is for this exterior panel. Now we did the calculation for this panel as well. Clear? And you see here 351. So 351, 75% will be here and rest of will go towards here. So let me 0.75 times of you see 351. So you see 263 will be here. Okay, let me write down here 263 at the other face of that support. 263. Okay, 263. And the rest of the movement, let me show you in another way here. Okay, the total movement is how much? 351. So 351 minus this one divided by 2. 351 minus this one, 263. 263 divided by 2. Or either you can take 12.5%. So you can use both, okay, both way. 351 minus 263 give you this much, 89. 89 divided by 2 give you 44. Round about 45% you can write. So 45%, 45 will be here and 45 will be here. Okay, this is important. And the next 35%. So you take 35, 189. So you have to now 60%. So here you have 60%. So 0.6 times 189. This is 113. So 113 will be absorbed here, while the rest of the movement mean that here you have 189 minus 113 divided by 2. So minus 189 minus 113, it give you 76 divided by 2 give you 38. So there you have 38 and here you have 38. Okay, or either you can take 20% of 189. So 20% of 189 will be equals to 38 and 20% of 189 will be equals to 38. So this is the way. Okay, here you see, look, 140.00, 168 equals to 112 divided by 2. 112 divided by 2 is 56. 283 will be here, while the rest of 94 divided by 2, 47. And similarly you see the calculation, 263 will be absorbed here, while the rest 88 divided by 2 is 44, 45, 113 and 76, and again the same calculation will be repeated. Okay, so this is for longitudinal span. Okay, now remember we have to convert now these movements to per movement per strip width. Remember, this is not per strip width. Okay, this is basically, you see, this is 5 feet. So this movement you see here, this is, here we have let's say this is, I think so, 56. So this is 56 is total movement and this width. Now you have to divide this 56 by the column by the middle strip width. So you got per strip movement. Okay, so once you divide all those movements, you got these values. Okay, the values: 56 divided by 5, 47 divided by 5, 38 divided by 5, 45 divided by 5. All these, remember, there you have to divide 168 divided by 10 because the column strip width is 10. Okay, 10 feet. And 56 here, the middle strip width is 5 feet. Remember, so you have to 56 divided by 5, but 168 divided by 10 and 56 divided by 5. So you got these values. 11.2, 9.4, 8.8. Okay, all the values you got in second step, you have to just divide them by 5, and these values will be, okay, let me check it. 56 divided by 5, I got what value? This is 11.2. okay, this is now 11.2. this is remember, it will be kept where we have this 11.2. now it is converted to movement per step, mean that this is now kept as we did in calculation, kept feet per feet. Okay, so this is that way of representation of low moments. Okay, so you did the calculation for interior frame. Okay, now we have exterior frame. So you just, to find out your L1 will be same, that is 25 feet. Okay, center to center distance. Your external panel, internal panel, L2 is different, and I already explained that why this different. You have to just this 20 divided by 2 plus that half. Okay, you have to add it. So that's why L2 will be different. You see here, L2 is the panel width divided by 2 plus h divided by 2. You got 10.5 here. So the width of the column strip, remember, there you have to no need to find out half column strip. You just to find out the column strip width. So the column strip width is 20 divided by 4, minimum panel width divided by 4 plus 1, 2, half times of, remember, this is very important. I already explained the point. Okay, I already explained this point in lecture number 4. Okay, in exterior panel you have to remember, look, that once you divide the 20 divided by 2 from the, you got the from the center of that column to this edge. Remember, this is 20 divided by 2. Okay, and the column strip width is basically from the far edge of the slab to that one. Okay, so this is your column strip width. So you have to add up that half. Okay, now the column strip width is what? Column strip width is L2 plus the half. Okay, but minimum of L2 or minimum of L1, remember. And you see all the calculation, column strip width is this much, and middle strip width is nothing. It is middle strip width is how much? That is your L2 minus your column strip width. Okay, so L2 minus your column strip width, that is this one, so 5 feet. Okay, so this is, remember, and here you have, I write down here, this is my column strip width and this is my middle strip width, and the only difference is there that there is only one side column strip and middle strip, no half middle strip and half column strip, remember. And the rest of the calculation is same, WU, L2, ln square, all the values are same. L2 is different, yes, L2 is different because this is 10.58, in that case that is 20 feet, and ln is same as previous. Okay, and you have to find out, this is now your M0. Okay, this is your M0. Again, M exterior negative, M exterior positive, M interior negative. You have to use, this is round about 26, this is 52, this is 70, this is 65, this is 35. Okay, we use all the coefficients, we got these values. Okay, these are the longitudinal distribution. Now you have to distribute in transverse direction. So for transverse direction, you see your coefficients. Okay, 0% will be here, 0% will be here, sorry, 0% will be here, 100% will be here, and 60% while 40%. Now no need of 20% because they are only one side middle strip. Okay, one side, so 40% will be here. Okay, 25% will be go towards transfer towards the middle strip. So the same calculation, just you don't need to take half. Clear? And now once you use the coefficients, you have to write down your values. This 74 is basically from where it comes out, this is this value. Okay, 74, but here 60% of what? Of this moment, 60% of 148. Let me check it. 60%, I 0.6 times 148 give me how much? This is 88, and you see 88.8 I got, I round up 89. Clear? Now the rest of the moment, total moment is 148, so 148 minus 89, 148 minus 89, give me 59. So here you see 59. Okay, so this is the way. Similarly here you got 75% of this moment, 75% of 200. So if you take 75% of 200, you got 150, and 25% of 200, you got 50%. Or either you can got this 50 by just subtracting 150 from 200. 140 is 75% of this moment, 186, while 46 is as I take 75%, so 25% of 186, I got that one. Okay, and yes, in negative or in positive, remember this is this 60. Now from where this 60 comes, remember 60% of your M positive movement, 100. So you just take 100, 60% of your 100, you got 60%, 60, while 40% of 100 is 40, and rest of the calculation will be repeated as usual. And then you have to further divide that movements into movement per foot length. Okay, movement per, this is, remember these movements per strip in this direction. Now you have to convert them into longitudinal direction. For that purpose you have to divide 74 by the column, by the column strip width, remember, and the column strip width is 5.58. so let me check it. 74 divided by 5.58, I got 13.26. yes, this is 13.26, and here is 0. 89 divided by 5.5, you got this one, and 59 divided by 5, 59 divided by 5, you got 11.8, because the width of the middle strip width is 5 feet. Okay, so finally you do all the calculations, and for east-west direction you analyze the frame. Now in next lecture, inshallah, that is lecture number 6, we do the analysis for the north-south direction. Okay, but the same calculation I just go through it. Okay, and I don't give you much of time. Okay, so thank you for watching. See you in next lecture.